Good morning, everyone. Thank you for joining me this morning. For those of you who don't know me, my name is Rob Sarmanian. I'm the General Manager of Oakson, and I'll be presenting to you this morning. There's a few people who are having some difficulties getting into the portal here, so I'm going to give them another minute before I jump in, so stay tuned. I will be right back. All right, welcome back. We'll get started. I wanted to go through some logistics first, just so you can understand the platform if you haven't been on this one so far. So based on the number of attendees we have signed into this webinar, I'm going to keep everybody muted. Just from experience, the background noise and whatnot can really overwhelm the presentation, and then I end up having to mute people anyway. So questions are welcome, and hopefully I get a ton of them. The way to handle questions is in your dashboard, which if you look, I believe it's in the top right-hand corner, there'll be a little arrow. You can expand a dashboard that will give you a question bar. So when you type a question in, it only comes to me, and it's not going to be, the rest of the attendees won't see it. And I will read it aloud and answer it, but it may not be immediately when you type it in, because there may be a section later on in the presentation that will address your question. But in either event, it will be discussed. And secondly is there is a handout in the portal as well, the New Hampshire Design Manual. You can download it right through this platform, or you could get it on our website later on. So that is about it, and let's get started. So in today's session, we'll go through some introductions. I'll walk you through the concept of Perc-Rite Drip Dispersal. We'll talk about the New Hampshire approval. I'll walk you through a design, some installation options, because there's many different ways to install a Perc-Rite system. We'll talk about long-term sustainability of the technology. And then lastly, I'd like to talk about some trends that we've been seeing for types of projects that engineers and designers have been specifying all over New England. So that may be of some interest to you. We are going to focus on residential size applications predominantly today. Occasionally, I'll make a reference to some larger projects just to give you some context on how the technology can be implemented. But for large flow designs and large flow systems, we're going to be hosting a very specific webinar next month. So if that's of interest to you, you'll get a notice via email, or just check on our website for the sign up, but that will be coming up probably the tail end of March. So I'd like to get to know you guys a little bit first before we get started with the presentation, because it's helpful to understand who my audience is. So I'm going to put a couple of poll questions out there, and if you could respond, that would be excellent. So first question is, what is your role in wastewater? Are you a designer? Do you do installations? Are you a homeowner or developer perhaps? Are you a regulatory official? Or do you work in operation and maintenance of wastewater systems? So everybody's trickling in. Give it another 15, 20 seconds. So 82% of you have voted and 100% of you are all designers. Fantastic. Okay, next question. What is your experience with Perc-Rite Drip Dispersal? This webinar is your first exposure. You know a little bit about the technology, but you're here to learn more. Perhaps you've worked with a project before. Maybe you're just here for the CEUs, which is just fine. So I'll give everybody a little bit. Don't be shy. I don't know if you here just for the CEU, so it's a blind poll. 64% have voted. Let's get a couple more. All right, well, the results are in. Half of you know about the technology, be here to learn more. A quarter of you have worked on a project before, and a quarter of you are here for the CEUs. Very good, thank you very much. All right, I am going to shut off my webcam so you can get a full screen experience with the presentation, and plus you don't want to look at me. You'll have to listen to me. Okay, so Perc-Rite Drip Dispersal is a national product. It is made in Virginia and is distributed throughout the United States and in North America. Oakson is your New England distributor of the product. So we cover all of New England. So here you can see our territory, and what's great about this is that we have approvals in all 6 New England states, and we can discharge, primary strength wastewater, so just a septic tank, or pre-treatment that precedes Perc-Rite if needed. Here's a little snapshot of Southern New England. On the Oakson.com website, there is an interactive map on the home page. So it's set up like a Google map, but it's has a lot more to it. All of these little droplets represent a system that has been installed. The green droplets are residential size systems, and the blue ones are larger or commercial systems. So this is a snapshot of Southern New England, and this is a snapshot of New Hampshire. So I wanted to be really forthright here. We have 4 systems installed in New Hampshire. That's it. And I threw those poll questions out to you, but I'm going to throw out another poll question that there is no place to answer unless you'd like to shoot me an email. We've been doing this in New England for over 15 years and have over 1,000 systems installed in the region, but only 4 in New Hampshire. So it would be great feedback if you folks, you designers, could let us know, what is the, reason perhaps that, Perc-Rite may not be used. And I have an inkling of what some of them can be. But I think in this presentation, I'm hoping to open some eyes on some of the projects that could be implemented. We know that it's not for every site, and we know that there are other options out there. But there are certain unique situations where you may have scratched your head saying, I really don't know, what to do here, and Perc-Rite may have been the answer. So stating that, let me just walk you through a little snapshot of each of these 4 sites. And then I would ask you to ask what's the common denominator there. So the first one is in Durham, Cedar Point Road. The second one is in Epsom. Number 3 is in Barnstead. and number 4 is in Alton. So it doesn't take a PE to understand that all 4 of these are waterfront examples. So one of the things we'll discuss during the presentation is how Perc-Rite is a great choice for environmental protection. So all of the projects that we have successfully built in New Hampshire all have that common denominator of their waterfront projects. 1 of them on the coast and 3 of them lakefront situations. So on the map, let me just go back for a second. If you were to click on one of those green dots, it'll bring you to these pages. So you'll actually see a close-up of the site, and then also be another box that opens up that tells you when it was installed, the year, how many gallons per day it is, the level of effluent. Is it a primary effluent disposal system? Does it have treatment? Et cetera, et cetera. So it gives you a great snapshot of information if you'd like to learn about, when these were installed, or if you'd like to look at other projects in Vermont, Massachusetts, Maine. There are hundreds of them to look at and see, maybe why somebody may have chosen to use Perc-Rite there. All right, enough. So let me talk to you about the history of Perc-Rite and how it came to be. In the 1970s, the Middle Eastern countries had an issue with how to grow crops. It's desert based. Most of the countries. So they worked through some things and came up with a process to pump treated wastewater from the cities, pipe it out to the desert, and irrigate crops through subsurface irrigation tubing. So that's basically the genesis, the birth of how Perc-Rite came to be and how wastewater was used as a method of irrigation for agricultural purposes. In the 1980s, that concept was brought to the United States. A pioneering engineer thought it was a great idea, not so much to irrigate crops, but as a wastewater disposal system. So that engineer went through the patent process, and Perc-Rite was born, and the first systems were installed in 1990, and they were installed in the states of Pennsylvania and Virginia. So from a longevity standpoint, we can point our finger to 1990 as the first systems that have been installed. In the region, in New England, Mass DEP issued our approval in January of 2006. We had systems built that same year. New Hampshire DES approved Perc-Rite in July of 2009. The first system was installed in 2011. And then finally, the last state approval was issued in 2015, and that was the state of Connecticut, which has very, very different regulations than all of the other New England states. It seems like the 5 other New England states have more of a commonality, and Connecticut is a little bit different. So that took him a little bit longer, and there's a lot more red tape for it to go through to issue that approval. So the concept of Perc-Rite, we are equivalent to pressure distribution. So under your state code, whenever pressure distribution needs to be utilized, Perc-Rite can be an equivalent substitute. So that's a very important concept to understand. We can discharge primary or treated effluent. It can be implemented for new construction or for failed systems, repairs, upgrades, etc. And let's walk you through a plan view of this. So we have a home that's discharging waste into a primary tank. So it can be either a septic tank or an aerobic treatment unit. It carries over into a separate pump chamber. In that pump chamber is a Perc-Rite supplied pump. It pumps through a force main into a device called a hydraulic unit. We'll go over what that does more specifically throughout the presentation. The hydraulic unit is just a pass-through. So the pump is back here, and this provides some other aspects of our system. So once it passes through the hydraulic unit, through a zone supply force main, through a zone supply manifold, so there's a manifold, and it feeds a series of interconnected pieces of drip dispersal tubing. What's important to note here is that this is not a perfect flat rectangle. We have a jog here to avoid a tree. We have different spacing to go around a tree. So quite different than some of the other disposal methods maybe you've worked on before. And then what's quite different is that we collect the wastewater through a return manifold, and it gets piped back to the hydraulic unit through a return force main. At that point in the hydraulic unit, it typically just deadheads, it stops there. So now the system is on, it's pumping and it's dripping. That collection point, it just stops. Once in a while, the control panel is going to open up a valve in this hydraulic unit to allow the wastewater to flow at scouring velocity through this tubing and then return back through a gravity return line into the inlet side of your primary tank. The reason for that function is that you have potentially, primary strength wastewater in very small diameter pipe, and it could grow slime in there. That scouring or flushing cleans the tubing and returns that slime back to the primary tank for settling. So the tubing remains clean. Very important. Okay, so that is the process of Perc-Rite Drip Dispersal. Here is a sort of cartoon rendering of a Perc-Rite system. We have a lot of people walking around somebody's backyard. I don't know why, but that's the way it is. So when you have a collection of tubing like this, we call it a single drip dispersal zone. So a single zone has one supply force main. For larger projects or projects with terrible soils that you need more area, there may be two separate zones. So they will have two force mains. But the 99% of residential systems will have a single zone setup. So there's our septic tank or treatment tank, carries over to the pump chamber. We have the hydraulic unit. We have that force main that feeds the hydraulic unit through the Perc-Rite supplied pump. We have the supply force main and the supply manifold. We have the return line and the return manifold. We have the gravity return line that brings it back into the inlet of your primary tank. We have the control panel, which controls the whole operation. There is an air release valve, both on the supply and the return manifolds. What this does is it allows air to evacuate the system during pressurization. So pressurization of the tubing can happen, almost instantaneously. And then the air valve also acts as a vacuum brake for when the pump shuts off. It allows air to come back into the system to evacuate the effluent out of the purple drip dispersal tubing. So the system, when the pump is on, the lines fill up and it drips. When the pump shuts off, the air valves allow air back in, and all of the effluent drains out of the drip dispersal tubing very quickly. So the question has come up in the past, well, wouldn't this freeze in New Hampshire or Maine or Vermont because it's shallowed, buried pipe? And the answer is it would if it remained full at all times, because there's a draining mechanism it allows it to operate for year-round systems in New England and for that matter, the northern New England climate and Canada, because we have a lot of systems in Canada as well. So all of this is a Perc-Rite system. All of these parts, the purple tubing, the hydraulic unit, the pump floats inside the tank, the control panel, the air valves are all supplied by Oakson. So if you specify a system, you do not have to specify and come up with a hydraulic unit configuration. You don't need to size a pump. We do this all for you. It's a pre-engineered system. We do not supply the rigid PVC pipe. It's just common Schedule 40. We do not supply the tanks. So, but all of the proprietary parts that are needed to build the Perc-Rite system are supplied by Oakson. So this picture is really interesting in many ways. When we build the system on a sand bed, we'll do a clean water system startup when the system is complete. And we'll notice these wetting fronts equally spaced and just about the same size at a very specified spacing, but also it provides a very uniform application throughout all of this tubing, and that's by design. Perc-Rite Drip Dispersal doesn't just randomly spray, effluent just, wherever there's a hole in the pipe. It is a controlled application, which gives us the opportunity to have a pre-engineered setup that is controlled and that provides uniform distribution throughout the entire soil interface of your system. So whether it is imported sand fill or if it's natural occurring soil, these tubes, these runs can be installed in natural occurring soil, that is approved under your state code, and interface with them to provide a uniform application. The magic is completed through this device called a pressure-compensating emitter. And this is what it looks like over here to the left. So one of these is embedded behind every orifice inside the drip dispersal tubing. And here's the operating curve. And it's really important as to how the system works. When the pressure inside the drip tubing is between 7 pounds and 70 pounds, the same application rate is applied, 0.61 gallons per hour for every orifice or every emitter. So these are spaced 2 feet along the drip dispersal tubing. So every 2 feet along the pipe, there will be 0.61 gallons over the course of 60 minutes. It's a very small amount if you think about it, because a pump's only going to run, 10 or 12 minutes typically. We'll decide that the pump runtime as part of the package, but it's a very, very small controlled amount of wastewater that's being applied to the soil. Now, during the 0 to 7 sequence, so as you're pressurizing, the pressurizing is very instantaneous. So you get to that 7 pounds pretty quickly and it starts dripping. When the pump shuts off and it drips a few more times and then there's a pressure drop and then the air valves even decrease the pressure more, the emitters allow the effluent just to flow out, so it just drains. So that's how the system drains at the end of the pump cycle. And the way that these emitters work is that there's the intake in the device, the wastewater goes over these teeth embedded in the device, and there's friction and there's loss. The pressure inside the emitter is less than the pressure inside the tubing. So that pressure differential forces a little rubber diaphragm to depress, and one droplet of water comes out of the orifice outside of the tubing, and then it recoils and the process happens again. So that occurs about once every second. So that's how you get that very low rate uniform applied wastewater throughout the entire soil. Here is a piece of drip dispersal tubing in action. It's upside down just so we can kind of see what's going on. This is one drip, one droplet of water. You notice that it didn't spray out, all right, or we wouldn't have been able to capture the picture. When it reaches atmospheric pressure, it just dribbles. So if this were upside down, as it normally is oriented, you'd have one drop coming out like a leaky faucet in your house. If you were to put your thumb and try to hold the wastewater back, there's enough pressure inside that forces it out that it would leak by your depressed thumb. But it doesn't spray if there is no resistance there. It's just a drop. So that's why there's no like erosion or no spraying, as you would see when you do a pressure distribution system and you're working on your squirt heights and whatnot. That's not the case here. It's just a little dribble into the soil. In order to achieve balance throughout that zone of tubing, a manifold is built, as we showed in the depiction before. So this type of manifold that we call the side feed manifold is very similar to your traditional pressure distribution type system. We'll have a force main below grade, horizontal pipes below frost depth that will, tee or elbow up and feed your lateral pipes. That's the same case here for Perc-Rite. So flat sites will get this type of configuration. You'll notice that we have an insulation barrier for our pipes that go up. That really helps protect the system for year-round operation, because these vertical risers will be charged. The drip tubing is not. So anything kind of in this insulation box will be charged. So when the system gets turned on, it's instantaneous pressurization. These little painted in sections here will represent the loop connections. So every line here, there's 8 of them, will be a run of drip dispersal tubing. These are your loops. And then because there's a supply and a return manifold, it'll alternate a supply feed here, a return here, a supply feed here, a return here. So it's broken up into 2 uniform laterals that provide a good pressure base into that tubing to keep it in the range specified. What's really unique about Perc-Rite and what helps us a lot on challenging sites is the ability to build drip dispersal zones on quite steep slopes. There is no maximum slope for which the system will not operate. There are maximum slopes in some of the state codes that say you can't, build more than a 30% grade. Or heavy equipment sometimes is difficult to operate on steep grades, but Perc-Rite can be built on steep grades a lot of the times by hand and just cast the material from below and make it work. But in this case, in this example, we have a pretty good slope here. The pump chamber is further away at the toe of the slope. So you would imagine that the pressure closer to the pump, lower in elevation, would be greater than the pressure further away from the pump and higher in elevation. And of course, the answer is yes. But because of the pressure compensating emitters, the pressure up here may be 20 pounds. The pressure down here may be 40 pounds. But you're getting the exact same application rate throughout the entire network of tubing. Now, many of you design, I know we have a lot of designers because we did the poll. For those who have designed pressure distribution systems on a slope before, it is a nightmare. There'd be ball valves at each of these laterals, perhaps different orifice spacing and sizing. So your squirt test, you have to do a lot of adjustments and whatnot just to make it all work. Not with Perc-Rite. Pre-engineered The pressure compensating emitters takes care of all that, and you get uniform application throughout the entire zone. So this will be the kind of the only time that I'll remind you that you have the question tab in your dashboard. Happy to please type in a question at any time, and I'd love to bring it to the group. So this is the last warning. Okay, let's walk through the approval. So our approval was issued in July of 2009 from DES, and it gives us the ability to discharge primary and secondary treated wastewater. So it's all in here. There is a table that helps us size the system, that is part of our design manual, and this was all approved through DES. So the main things to think about here for the approval is that for systems with primary strength effluent, there's the 4-foot separation to your restrictive layers, a 2-foot for treatment. So that's fairly consistent, okay? There is an approved chart located in this table here that's gonna help you size the system. And the size of the system is really gonna be determined on the methods of construction and the type of limits you have on a site. This chart will give you the amount of linear feet required for your system based on your percolation rate and your design flow. So it's going to give you a linear footage, and then that linear footage will determine the area. And we'll walk you through some examples later on. But before we head on to the next slide, we have our first question. Thank you very much. So the question is, what is the recommended dose per day? I'm going to talk about that a little bit more later, but because we are time dosed, we are going to dose infrequently. So maybe 10 to 12 times per day over the course of 24 hours. So it's not a demand dosing situation. A timer will dictate when the system is dosed, because we want to use 24 hours throughout the day. So on average, it's somewhere between 10 and 12 times per day for a residential system. So thank you for your question, and that will be expanded upon later on. So how to size the field. We are going to calculate the amount of tubing through that chart that you just saw, and then we're going to figure out our installation method. So if you needed to use a sand bed, let's say there was unsuitable material or high groundwater forced you to be above grade, we can place the tubing 1 foot on center. So therefore, your linear foot to square foot ratio is 1:1. So if you needed 450 linear feet of drip dispersal tubing, you can build that in 450 square feet. Now, another example. Let's say your groundwater was deep enough and your soils were acceptable, your native soils, so you didn't have to remove anything, but you wanted to work around trees. And your site was big enough that you didn't have to squeeze it into a minimal area. And let's say we want to keep trees. So maybe we put in a piece of tubing on one side of a tree, go 2.5, 3 feet over, put another piece of tubing, then maybe go 1 foot for a couple of runs, then work around a few trees. The overall result may be a footprint that is a little bit bigger than what the bare minimum under the code would require, but because we did not need to strip out material and import sand, it's okay, because we didn't need to do that. So maybe the footprint is a little bit bigger under those circumstances. So the size of the system is going to be driven by the site conditions and the type of the way you're going to install it. The only thing to think about that is if you're dealing with new construction and you need to maintain a reserve area, the tubing must be 2 feet on center if you want to count the area in between the tubing. If you have another area you can designate and leave as reserve, then you could kind of space it a little more closely. So that is design criteria. We'll walk you through a real system later on, but we wanted to go a little bit more in depth about how this all comes together. So a residential design. How do we help you? This is your first time considering using Perc-Rite Drip Dispersal, and how are you going to pull this off? Are you going to be a lone wolf, or are you going to have support? You're going to have as much support as you desire. So as I mentioned, we have our New Hampshire design manual attached to this presentation. That's one way. If you really want to read and learn about how to design a Perc-Rite system in detail, you can do so through the manual. But in today's world, YouTube is a great source to learn how to do things. I just fixed my my clothes dryer last week. I couldn't get a repair guy out, so I said, you know what, let me figure this out. So I went on YouTube, found a video, and within 2 hours I'm back in business. Same thing here. Oakson has a YouTube channel, and in that YouTube channel there are videos to teach you how to design a system in detail. So we'll walk you through the process. I know that I am a much better learner now through video, through reading lengthy technical manuals. So that's an option for you as well. Coupled with those videos on our website and our YouTube channel are all of the aspects of a design that you will need. I know there are some of you on this presentation today that do work in Maine and Massachusetts. Those manuals and approvals are on our website. There is a written installation guide if you choose to want to look at that, but there are better YouTube installation videos available to you, and I'll walk you through one of those later on. All of the AutoCAD details that you would need to accompany your site plan are available. There are some in-depth questions that might help you, get to some solutions. And then lastly, there is a design calculator tool that if you put in the dimensions, let's say you do have a more typical rectangular shaped system, you can put in your length and your width, and then it'll spit out the exact manifold that you will need to build its system. So a lot of resources available to you. But if you choose to forego all those resources and you want to work with me directly for your design, please do so. I enjoy that interaction. So you might send me, a somewhat crude sketch because you really don't have, a developed site plan yet, and say, hey, Rob, I got this area. It's about 375 square feet. We have, a dwelling or a garage over here. We got this, we got that. What can we do there? Or maybe you have something a little more detailed. Rob, we have this house and that we have a beautiful deck here, and then a paver driveway, a lot of trees, a nice walkway. We have to stay away from this water line. I only have this very small area. There are some trees we want to keep. There is some slope. What can we do? Is Perc-Rite a possibility here? And I'll work with you, during those circumstances. But what I found is the best way, and if you're a little bit more further along, maybe you've worked on another solution on a site, and maybe that solution is causing you heartburn, and you're like, this isn't going to look good, or this is going to be really expensive because I need a huge retaining wall. So maybe you send me existing conditions, right? Your design calculations, your plan intent, things that you've already worked on, and then some other, tank locations, some potential field layout. I can work with you and give you back an exact Perc-Rite layout for those circumstances, okay? And this is one of those 4 in Durham of an actual site plan. So you see here, we had to work around an existing well radius. We're right on a body of water. We have to follow an offset for that body of water. We had to maintain an offset to the dwelling. We had to maintain a minimum offset to certain to the road and whatnot. So a lot of things here we had to work around, but because we had that great back and forth, myself and the designer, we came to a very, very good solution that was applied in the real world. So this is a snapshot of the secondary details and notes that we'll provide to you as part of the AutoCAD tab on our website. And these are designed to be modified slightly as needed. So we'll give you a profile, but maybe we need to change some of the wording on the notes based on the depth or soil removal needed or where your water table is, right? Maybe this is a 2-zone system instead of 1, but but it's all there and it's all easily modified to fit into your particular site plan. So let's talk about, again, just some of the design criteria. So here is our chart. We are calculating linear feet of tubing, not area. And that's based on your perk rate and your design flow. Just plug it in this chart and it'll give you a multiplier in order to come up with that linear feet of tubing. All right, so that is pretty much what we're going to talk about for design. This is only a 2-hour presentation, so I can't go into too much detail on that. Otherwise, we won't be able to touch all of the topics. So a good question just came in about design. So talking about perk tests, if the tubing is only 8 inches in the ground, then where do you do your perk test? So great question. So the answer to that question is when you're designing a system, you need to design it based on the most restrictive layer, okay? So if your most restrictive layer is deeper down and you want to do your perk test, say in the C layer, in that the A and B layer is less restrictive, then with Perc-Rite, you would be able to maintain that, right? And do it shallow. If your A and B is more restrictive, then you need to be a little bit more creative. Whereas you may have a shallow perk test, or you may be perking, through a couple of different layers, and you would need to work through that with your regulatory official. It's a little bit unique in that aspect. So, and sometimes I've known the people have done the sieve analysis to figure out what the saturation rate is for that particular soil. So yes, because it's shallow and because it's a little unique, some of the perk testing does end up being a little bit unique as well under those circumstances. So let me just describe to you a large flow design. We do have systems in New England, designed and implemented up to, I think the biggest right now is about 160,000 gallons per day. So this can be used on a 2-bedroom home all the way up to, a town or a school or a commercial building. So here is an example of a large a large residential subdivision in Rhode Island where they had a treatment plant and then they had pockets of soils that were good throughout the site. And so you see a lot of jogs here, and that's because they were avoiding some bad pockets of soils. So we had a very unique zone layout, not a problem, because we will provide to you all of the custom details needed for your site. So anything you need as an engineer, we will work and give to you. And then what's most importantly is with these details, and that you'll need to size your pump and your force main, we're going to give you all that information. So we're going to provide to you the zone layouts, what your pump needs to be, how many runs in a zone, the force main size, how many minutes per day the system needs to run, all of the factors. And this is just one little snippet of a 5-page report that we are going to give to you that shows you how we came up with our design. And then you can obviously make sure that our math is correct, but you don't have to go through that process. We're going to give it to you. We'll give you the answers to the test, and then you can just read through the questions and make sure that you agree with our answers. So if you're a regulator, and there weren't any on today, but this is important to know that there may be a regulator that has no idea what Perc-Rite is. So you as a designer is turning in a plan to somebody who's going to say, what is this? I don't even know, how to what to do here. Not a problem. Encourage your regulators to reach out to us, and we can provide them all the information they need to review their plan. We can also review it with them. I've been known, actually pre-COVID, to go to offices and sit down and roll out the plans and walk them through the approvals, show them everything, and make sure they're comfortable. We've been to meetings before. We do a lot of stuff to make sure that everybody is comfortable and understands, how the technology works, and that it really is just a more protective, pressure distribution type system. When a project is completed, we're going to issue a letter to that regulatory official or the committee, a letter of certification. So Oakson's going to say, we started up the system. It's working according to the design plan, according to the state approval and the manufacturer specifications. It was started up this day. It was designed by X. It was installed by Y. It has a maintenance contract with this O&M company, and it's all ready to go for final sign off. So that's something that we'll do. But in the long term, even though we are not providing the maintenance for the system, because we deal with third-party companies, and I'll talk about that more later, but we are going to remain on as a consultant for all of our systems throughout the life of them. Maybe the maintenance company has hired some new people, and some of their existing people have left and they need some advanced training. Or maybe there's a part they need for a system, or maybe they're just have questions and they need some help at a site. We are going to be available for all of our systems, whether they are small residential size systems or large commercial systems. So we will be a consultant for all of our installations throughout the life of their existence. All right, this next section is really, I think, that interests everybody most, even designers, because putting these in is quite cool. So, and I'm actually we're doing one tomorrow. We got a little break in the weather the last couple of days, so a very eager site contractor in Massachusetts is saying, hey, let's get this in. I want to be first to go for the build season. It's important to differentiate roles. So what does Oakson do for every installation project, and what does the site contractor do? So what Oakson's going to do is we're going to work with the site contractor to plan things out. So we're going to review plans with them. We'll provide a list of parts that we are going to supply, like when I talked about during the rendering, and then items they're going to need to supply. So basically the Schedule 40 pipe. We'll even give them takeoffs of that, just so they have a really good understanding of, they don't have to think it through too much. We're going to give them the electrical schematics for the project. We're going to give them links to our YouTube channel so they can watch an actual installation in depth. They will feel a lot more comfortable after watching the video than trying to figure it out on the plan, believe me. We're going to provide a technician to go to every single one of our installations. So we will have an Oakson technician during the installation of our components. And the goal here is we want to remove the guesswork from the construction process. We want the contractor to be confident in the bid they put out for the installation, and we want them to be confident that when we say we will be able to build this in less than 1 day, so long as you follow our lead, we want them to have confidence in that. The contractor will supply and install all the tanks. Talked about that a little bit already. They're going to prepare the drip dispersal area. So if it's a sand bed, they're going to do their excavation, their scarifying, and bring the sand bed and have it raked out, ready to go before we get there. If it's a plowed in installation, maybe they're going to flag or stake the area. Maybe they're going to paint some contour lines and just get ready. They'll provide all the pipe. They're going to work alongside us. So Oakson is not the contractor of record. We do not pull permits, but we are going to work alongside. What I say is, we're going to be in the same trench as the contractor installing our components. The contractor will be responsible for securing an electrician. So whether they're going to use their person that they'd like to use for wiring, or maybe the homeowner has somebody they want to use, but it's their job to secure the electrician and have them ready to go for the day of installation. The contractor is responsible for backfilling all the components and following the backfilling procedures that are given to them. And then also that they will work with the engineer and the homeowner to make sure all of the compliance documents are taken care of. Oakson does not deal directly for compliance documents other than issuing that letter of certification. Since we are not the designer of record, since we are not the contractor, we're sort of like a third-party vendor. We will help make sure everything is in place, and our letter typically does that, but it's up to the contractor and the designer to make sure all compliance is taken care of. So let's look at how some of this tubing gets installed. A sand bed. So this is kind of the most visually impactful, photographs we can show, because you actually see the tubing laid out, right? So the picture on the left is the site before the tubing was laid out. And what's interesting to note here, it's not a perfect rectangle, so we have a lot of jogs, and we have a fair amount of slope. So the contractor has staked all of the jogs, making our life easier. And then we painted lines for where every run of tubing would be cut and staked down. All of these lines follow that contour. And then here you see the result right before the excavator is starting backfill. All of the lines are laid down. They're all following contour. There's little stakes in here that you don't see, but they look like sod staples. They hold the tubing down temporarily till the material's cast over it. Here are loops, and our manifold is up here. So that is a sand bed installation. Kind of ho-hum, but at least 50% of our installations are on sand beds. Here's where we get a little more interesting. So plowing it into an existing lawn. So the picture on the left, the contractor is providing paint marks to follow the contour. There's a little bit of a nice gradual slope on this beautiful lawn here. You can kind of see the trees down below. It's a nice gentle slope, and the slope follows a little bit of a curve. So the contractor had his laser level and walked along, and every place where he heard a beep, he did a little paint mark, and then he went back and painted the lines through. And you can see some of the lines here to the right in the machine plowing the drip dispersal tubing into the existing grade. At the far end, the little pigtails of tubing are sticking out. We'll see some better pictures later on, but the operator is following the contour, pulling the tubing in at the desired depth that was specified on the site plan. Now, this is a hybrid example of the first two. This example is used on large commercial systems. So you can imagine that maybe in a backyard, you might be, 24 by 50, something, or 12 by 50, something relatively small, where you could lay the tubing on a sand bed and have the reach of an excavator cover it. Well, this particular field is about 500 feet across and 120 feet in this direction. It would be impossible for a machine to be able to cast the material over it without having to kind of ramp up material and kind of drive on and off, on and off. It would be a nightmare. So we've come up with a process for which the tubing elevation is specified on the plan, and then additional sand of, say, 6 inches, a sand blanket or sand envelope is put over that elevation. So your tubing elevation is 100, the sand blanket is 100.5. Now that ditch witch can pull the tubing in at a depth of 6 inches below grade, and all the tubing is covered. Now a skid steer or track machine can drive over the sand and spread the topsoil very efficiently. I'm not worried about the load over the tubing. The tubing can be, compressed, it'll bounce back, it's not a problem. But if you were to drive over it with a machine, very likely would tear it up, and then, it's going to be, weeping all over the place, unintentionally. So this method allows very quick installation, and I'm going to show you some really, neat stuff on this more later on. Let's say you have a system in the woods and you have some roots or whatnot. You might want to use a chain trencher that cuts the soil. The cast material moves off to the side through this wheel here, and then you cut your tubing by hand, put it in the little trench, and then rake the material over. What's interesting about this system here was this was built in Maine, and there's a failed Presby system below it. The Presby system was about a year old. So they installed the in between the Presby trenches, the sand was excellent. It was perfect. So the site evaluator in Maine and came up with this idea, and the town approved it, that they just left the Presbys in place, trenched in between them for the tubing, and then connected it to a pump station over here. So it worked out quite well. So we see the chain trencher a lot in wooded sites where, you might cut through some roots and stuff, and you're not too concerned. Now, the last example, which is the most unique and to be quite honest, the most time consuming, is you have a homeowner who does not want to lose a single sapling, move a rock, move, a semi-mature tree, move a tree that's kind of falling down a little bit, although this is kind of like the last run of tubing, so this tree won't impact it. So they hired the contractor to hand trench with narrow shovels, just wide enough, going around all the obstacles, and then laying the tubing in these trenches. So it's very, very labor intensive, but the result is you have all of the leaf litter over here that they blew off to get started. Hand trenched, put the tubing in, raked the material over, made all the manifold connections, blew the leaves back, and you would never know a wastewater system is installed at this property. So here is Oakson working side by side in the trench, building the manifolds, and this was one of that side feed manifold that I showed you early on with the little blue paint marks on it. This is a different perspective with a dugout, so you can see the lines below frost, and then supply and return laterals feeding up through these insulated boxes. Everything gets backfilled, and you can lay your tubing. We are going to take a slight break that I am going to show you a couple of videos. They're going to be 3 videos, 2 of them of which have no audio, that I will act as your Morgan Freeman narrator and describe to you what's going on. The last video is going to be a few minutes of one of the very detailed installation videos that we have on our YouTube channel, so that you can see some of the resources we have available for your installation contractors, or if you just kind of want to see how it goes in on your own. So that one does have an audio component, so I'll just let that do the talking. But let's start with the first video. So here's that same site where we're pulling the tubing into the lawn. You can see the paint marks that were for the next runs that the contractor painted out. And here's the operator getting to the end of the line. He's going to bring the blade up, cut off the end, and you'll have the pigtail there. They'll be looped together later on and or connected into the manifolds. Here is an example of the tubing being pulled in for a large commercial system, and you can faintly see like a string line along the track, and that's allowing the installer to pull it straight. As they get to the end, the string line's connected to the stake, and then they just move the string to the next stake and pull the next line. A lot of these in these videos here, I sped up the process, so we're just not sitting here for 10 minutes watching it plod along. But you get the idea. He reaches the end, cuts it out, and then you're all set. Here is installation video captured by a drone. So again, we are speeding up the video so you don't have to endure many minutes of this monotony. But the contractor makes it to the end. He pulls up, cuts the line, and then he drives off and goes back to the other end. As he's driving off, you can see the guys over to the left. They're moving the stakes, moving the string, and the one guy on his knees is actually making the loop connection, as everything gets set up. So this was a system that was 6,000 gallons per day for a residential cluster. All of the tubing was pulled in 5 hours. So all of the tubing and all of the loop connections were done in 5 hours with basically 3 or 4 guys. Really quick, really efficient. So here they are connecting again to the coil of tubing and starting the process again. So this company that's pulling in the tubing is an irrigation company that we've worked with on probably 20 jobs. And they're not part of Oakson, but they are often used as a subcontractor on a lot of jobs. The installation contractor is like, you know what? Why should I rent a machine and struggle through it when I can get a fixed price, a very reasonable price, and have it pulled in with certainty? So that's what's going on here. So here we are at the end of the line again. And that is the end of this video. So the next video I'd like to show you is an installation from a couple of weeks ago, just a quick snapshot. Actually, I'm having problems with that. I apologize. So we're gonna, says I have an error. Okay, that's all right. It's more drone video anyway. So I'm gonna show you an installation video. Please enjoy. All right, I'm back. That video continues on for about another 12 minutes or so. And in that video, we'll set up the pump, we'll build the float mast, we'll locate the hydraulic unit, talk about wiring, show the startup, laying the tubing down. It's all the whole process broken down into segments. So hopefully, that was informative for you. But if you have more interest to learn more about how the system is built and how it works, just go on our YouTube channel and watch the video. And all those videos can be accessed also through Oakson.com. All right, sustainability. So the very first Perc-Rite systems were installed in 1990, and probably about 4 or 5 years ago, American Manufacturing, the company that built the system, went back to some of their first systems and said to the homeowners, hey, look, we'd be real interested in seeing what this looks like. And they exhumed part of the system, cut out some of the tubing, put in some fresh tubing, looked at the soil, took soil samples and whatnot. And what they found is that because the tubing is installed in the upper soils in the oxygen-rich environment, there is no biomat forming. So biomat forms because of anaerobic conditions. Because it is installed in the upper soils, the bacteria and microbes that live up there don't have that little gelatinous stuff that they put over them, and that's what creates the biomat. So the soil was in excellent shape, 25, 27 years later. Now, of course, there's a pump, there are floats, there are little valves and stuff. Those have a lifespan, but we've seen systems that we've had installed since 2006 in Massachusetts with the same pump. So we can say with certainty that the drip field, because it is flushed out and because it's installed in the upper soils, is going to last, a lifetime. The other components, if you can get, 12 to 15 years out of some components, I would be, proud to say that we consider it all very durable. That soil is preserved also because of the time dosing. So we're not just demand dosing the field. So every time a shower is taken or a toilet is flushed or a load of laundry is discharged, the pump isn't coming on. That effluent goes through the normal settling process, carries over to the pump chamber, and then works like an EQ tank, a pump station, where it will just get dispersed a little bit every couple of hours over 24 hours until you get your design flow. So if you have a 3-bedroom home, that gets chopped up over the course of 24 hours and discharged. The little note here about simple repairs is that if you have a shallowed, buried piece of drip dispersal tubing, and if later on, if you're pitching a tent in your side yard and you accidentally drive a stake through the tubing, it's very easily fixed. Just a couple of barb connections and you dig down, you fix it. I mean, your maintenance provider can do it in 10 minutes. So it's very easy and it is not cost prohibitive when things like that happen. So operation maintenance, the recommended schedule is an annual visit for our equipment. If the system is partnered with a treatment system that requires more maintenance than once a year, it's okay just to kick the tires on our stuff. That it's a few minutes just to take a look at everything. But for just the Perc-Rite components themselves, once per year is more than enough to say that everything is working well. For large systems, we're going to provide a custom O&M plan. So depending upon the number of zones, the gallons per day, the strength of effluent and the type of treatment that may be before it, we'll come up with a plan with frequency, inspection points, all the things that you need for your large system. And then lastly, so when Oakson first came to be in 2004 and our systems were being built in 2006, we did the maintenance ourselves. And what we learned quite quickly is that you are either a maintenance company or you're not a maintenance company. You're not a part-time maintenance company. So it's just to be set up to have multiple service trucks, 24-hour coverage, and cover a territory like we do. It just wasn't feasible to provide the level of support that we want to give our customers. So we made the decision a few years in to, rather than do the maintenance ourselves, but to train those professional wastewater companies that do this for a living, give them all of the resources and experience they need to maintain these systems. And we found that there are quite a few of these companies out there that are taking on a lot of systems, and there are many of them that we have geographically spaced throughout the region that that can cover, you know, your territories. So just got a question that came in. So when you have a pre-treatment system in New Hampshire, you can take a reduction of size. Is that the same for Perc-Rite? So the answer is yes. So whenever we are partnered with a treatment system, you would size the system from based on whatever level of treatment you have and whatever variance you can take for size based on that treatment system. Then you would build the Perc-Rite system accordingly. So in that case, if you have a very small footprint, we will assist you at coming up with a zone detail that will fit. Normally, if you're taking a reduction in field size, then it's because you don't have a lot of area to work with. So maybe you're also building it in a sand bed and keeping it small. So very likely it'll be a zone detail that will work with you on that. So yes, with pre-treatment, you size it and take all the variances that are afforded to you under that particular system. Okay, let's talk about the components of Perc-Rite. So we do supply all these components, as I mentioned earlier. So we use a pump. The pump is a high head effluent pump. It looks a lot like a well pump. These are designed to work through different lift and distance considerations. They last a long time and work very well for the purposes of the Perc-Rite drip dispersal system. Our pump is not mounted like on rails or a pull chain situation. We build a little screen vault with this device we supply called the Cool Guide, and then it's attached to a piece of SDR35 with a bell, and that gets lifted into the riser, secured there. So there's a nice way to disconnect the pump, lift it out if it requires any service. So that is what our pump station looks like. So this is what that Cool Guide looks like. We have the device that we provided, and it goes all the way up into the riser of the system. And the way it works is that the water is drawn over in the middle, over in the intake, and is forced down over the motor and up into the intake. So it actually cools the motor as it works. So that's why they last a long time. The hydraulic unit, this is a residential example up here on the top left. And you can see that we have 2 disc filters. And you would imagine that if you're pumping septic tank effluent out to small pipe, you got to worry about clogging. Well, no worries here. The hydraulic unit takes care of that for you. So these 115 micron disc filters filter the wastewater before it goes out to the drip dispersal tubing. Anything that passes through here will pass through the emitter and the orifice. So you have no concern about clogging. Every one of our hydraulic units has a flow meter part of it. The flow meter provides a great diagnostic tool. So that uniform application, that pump curve that you saw for the emitters, we know precisely if you have 400 feet of drip tubing installed in your project, there will be 200 emitters because they're spaced every 2 feet on center. 200 emitters at 0.61 gallons per hour divided by 60 to get into gallons per minute would be 2.0 gallons per minute. When you start up the system for the first time and these dials are spinning, we can register the flow at a precision of 100th of a gallon per minute for this dial, but we typically use this dial where it's 1/10 of a gallon per minute. So every tick on the clock is 1/10 of a gallon. One revolution is 1 gallon. So once the system pressurizes, we'll start the clock and we'll time 1 full minute. We hit that 2 gallons per minute and we know that the system is operating correctly. Let's fast forward 10 years and you're at your annual inspection. The operator will check the filters, see that they're back flushing properly, run the system. You're hitting 2 gallons per minute. You know that everything is working fabulously in your 10-year-old disposal system. So that's how the system, works with the hydraulic unit. It is typically mounted on the pump chamber so that that force main feeds into it. It's quite, short. And then you have your supply and return laterals, force mains that go out to feed the manifolds and laterals. This picture here on the left is a large, on the right is a large hydraulic unit that's mounted inside the treatment building. And it also has suction lift pumps that are mounted to it. So sometimes on interior situations, we go with this setup and it works quite nicely as well. Here's our drip dispersal tubing on a boat headed over into an island installation. And there is another picture of the wetting front. As part of the system, we supply a control panel. It's a NEMA 4X enclosure, so it's designed to be kept outside. We want them outside so that the operator can do all of their routine inspections without having to come into the home. COVID pandemic, you don't want people coming in your house anyway, but if you think about it, if you have to come inside, you would need an appointment and make sure you're home. Whereas when it's outside, the operator can just tell you they're coming a certain day and get to their job quite easily. We often see these control panels mounted on pedestals near the pump station and hydraulic unit. Maybe the tanks are a little bit further away from the home and you can hide it behind a bush or something. So that's sometimes the case. For our larger commercial panels, they all have touch screen and SCADA interface, and they are mounted inside the building because that's where all of the equipment is. All right, what are some of the advantages of choosing to use a Perc-Rite drip dispersal system? Working with slopes. So we talked about the benefit of not having to design a pressure distribution system on a hillside. You can see all the way down here near the house, you have the tanks, you have the control panel being wired, quite a lift in distance. So working with a slope, we didn't have to make this a flat field. We didn't have to clear any downslope trees. This particular, it was better for them to clear these trees than to work around it, just because of the nature of the slope and the depth they chose to install the system. But you can see here that the final elevation of the system is going to be the exact same of the existing grade. Now, quite nice turnout there. And that's because the tubing follows the offset of your limiting factor, and then you just need to grade over it and then hold up your slopes. You don't need to build a wall here and make this flat. Otherwise, you'd have a lot more material. So because the tubing can be 6 inches below finished grade, we provide you the lowest profile option of any wastewater system. So in this particular example, you have a failed system that was right here, okay? So the contractor removed all the failed system and material. If any other system were built here, this side walkway, you'd have to walk up over a big mound, and you wouldn't have the access to the limited yard that you had to begin with. Not to mention this being a waterfront property. So all of these coupled together, when you have a finished grade of 6 inches, the walkway will be at the same elevation as the final grade of your wastewater system. This is a new construction situation. If they chose to use something else, you'd have to raise this much higher, which in turn would have raised the walkway, the entrance, and then likely the whole house would have had to be lifted in a higher foundation. Maybe you would have had a restriction on your height to build. So by keeping your wastewater system lower profile, you can have the whole building as low as possible and not be impacted for your height to build. Flexible layouts. So here's an example of a well radius that need to be followed. You have a sloping wooded site, quite a drop off here. So you end up with an hourglass shaped field with considerable slope. I challenge you to design a PD system in 5 minutes with this configuration. But with Perc-Rite, it worked out quite easily and nicely. Here's another example of a repair in a backyard where the outline of the system followed the setback to property line along the fence. So we built a right angle system. Not a problem with Perc-Rite Drip Dispersal. So overcoming site conditions. If you've seen our presentation before, this picture was taken in 2008. And it's really a very unique situation. This was a system built in the Berkshires of Western Massachusetts, and it's a camp on a lake, and you have another house, and we all know they all start as camps, but in today's world, lakefront property, they build them into micro mansions all along, the waterfront, and I've seen that on, Winnipesaukee in many cases. But you have what was started as a camp there. There's now a mansion, and you have one on this side as well. You're 20 feet to the lake, so you have no room. So what are you going to do here? You're going to have a tight tank, or you're going to try to dispose your wastewater. So they removed some unsuitable material, used wheelbarrows and put in some sand and built it under the deck and went around the pilings. Now, this is not a typical situation, but it's something that was very successful, and this is still operational today in 2021. So we wanted to show you the real extreme examples that we can provide to you. Here is just a simple utility pole, an electric pole in the side yard. Rather than paying the electric company to move it, we can just go around it and not have to worry about it. Here's another example of a well radius close to the dwelling, close to a deck, a lot of trees, property line offsets, a lot of challenges. Not a problem with Perc-Rite. So you're following all those nooks and crannies here. You have significant slope. All the vegetation is all preserved here. Here's some more plowed and trenched in installation examples. Here's a nice project we did at a 8,000 gallon per day camp up in Maine. So instead of ruining the existing camp area for the kids to play on, they plowed it in, made the connections, and they were back in business, really soon after installation. Here's that example, we talked about where you can pull in a piece on a cluster of trees, move over several feet, pull in another tube along a different cluster of trees, and another one and another one. So maybe the overall result was a bigger area than what the code, deemed to be the minimum area, but not if you're not excavating and you're not cutting down trees and you're not importing fill material, it can work out quite nicely for your client. Here's another waterfront example where they pulled in the tubing with a vibratory plow. No mound, no fill, no excavation. And if you think about it, despite having the barrier down below here, there's really no erosion concern, right? You know, you're not worried about any washout going down into the water because of the method of installation. Here's another close-up of that unique application we talked about earlier. Here is that sacred rock that they decided to go around, and just, you know, that little narrow trench, you know, every little root here and stuff, you know, preserved. So a question just came in, and it's how is the area calculated from the edge of tubing or whatnot? Actually, the tubing has a maximum of 1 foot on either side of it as deemed effective leaching area. So for so if you are placing it on a bed and you are spacing it at 1 foot on center, you would then have 6 inches to one side of it to your edge of bed. So it's basically whatever the space. If it's 1 foot on center, you would have 1 foot to the edge of the bed. If it's 2 feet on center, you'd have kind of 1 foot to the edge of the bed. Good question. Here's another example of, you know, just hand cutting this into existing grade. This was actually on an island, so they couldn't get any heavy equipment over there. So I want to talk to you about hydraulic failure. So we have a time dose system. We program the system only to run enough minutes in the day to discharge the design flow specified on your approved plan. So how does that prevent hydraulic failure? And I think we all can agree that the #1 reason for septic system failure is overloading it. And it's not overloading it because of use, right? It's not like we have, you know, kids or people are over showering or doing more laundry today than we've done before. The reality is our plumbing fixtures provide low flow aspects more today than ever before. So why do we have failure? Well, you have a bad seam in your septic tank. You have a bad collection system, right? That's taking in water. Or the biggest culprit, you have leaky toilets that are just pouring water into your wastewater system all the time. So how does Perc-Rite deal with that? Well, we deal with that by not discharging anything over the design flow, right? We have that flow meter. We know the exact flow rate. We're only going to pump if it's, you know, 2 gallons per minute and it's 300 gallons per day. We're going to tell the system to pump 150 minutes per day over 24 hours. If you are bringing in rainwater every time it rains because your pipe inlet is leaky, that tank's going to fill up and the alarm's going to go off, despite the system still running at its 300 gallon per day timer setting that it needs. So what's going to happen? Well, I'll tell you what's going to happen. You're going to have a homeowner who paid for a new wastewater system that got an alarm the first time it rained, and they're going to be very angry, okay? And I've gotten many phone calls from that, but usually what starts as an angry phone call results in a very happy homeowner because they replaced a system that failed because of hydraulic failure, and they don't want to do it again. So we caught that problem. So now the contractor came back and saw the weeping coming into the tank, sealed the tank better, and now we don't have that problem anymore. So that is how Perc-Rite is going to prevent hydraulic failure on your designs. So We have 4 New Hampshire project examples that I'm very proud of, so let me walk you through them a little bit more closely as we get to the end of our presentation. So there's one on Lake Winnipesaukee in Alton, so you can see it right here. Here is the installation contractor installing the hydraulic unit. They have the pump, they're getting ready to wire everything. You have the manifolds going over to the already installed drip dispersal tubing. You have the drip dispersal tubing at the other, so this is in the front yard, house, backyard is Winnipesaukee. So if you chose that little droplet on our website on the interactive map, you can zoom right in and see all the criteria. The one in Durham, New Hampshire. So this one is basically right on off of Piscataqua Road, which is lead kind of right over near after the bridge. So this is actually on the bay side. So you can see the docks here. Quite a lovely property. So here's that design plan that we showed earlier. So you have the water, the well radius, a very unique shape plan. They're connecting the manifold connections. You can see the water, see how close we are to the house. You can see the jog here following along the water line. There's a nice little boathouse here. The proximity to that tree, the proximity to the road. And there's the other side. So quite a lovely house. I wish I lived there myself, but needed a unique layout and a unique situation. Very, very tastefully done by Susan, the engineer on this. Sleepy Hollow Lane in Epsom. So you can see this here. So there is the New Hampshire DES representative inspecting the system. You can see it's right on the lake. But what was interesting is the designer of this system proposed a Presby that was going to stick out of the ground. The homeowner said, no way, I do not want a big elephant buried in my yard. I'm going to lose my deck. I'm going to have to climb over it to get to the rowboat on the lake. No way, find something else. So they designed a Perc-Rite system, and you can see the treatment. You can see the control panel here, the finish yard with spraying for the grass seed to grow. A very happy homeowner indeed. So in Barnstead, this is Upper Suncook Pond here. Very interesting site. This has been in the family for like 50 years, and they really wanted to bring it to the point where all the grandkids, and there was many of them, could use this for years and years and years without impacting the lake. There's been a lot of algae growth in the lake as a result of cottages that were only seasonal that are now turned into those micro mansions, and all of the waste that used to be in like little 30-gallon drums are now leaking into the lake. So this homeowner was awesome. He was an engineer in Boston and said, you know what, I want to take the lead here on the lake. I want to provide a solution that is going to allow my grandkids and my neighbors' grandkids to enjoy this lake and swim there, for long after I'm gone. So he worked and designed a treatment system with a Perc-Rite system. It didn't have a lot of room. So this whole area had to be tanks. And then you can see the tanks down here from the other perspective. And then there's this massive piece of outcrop that they wanted to keep, because when a grandchild was brought into this world, they always would put him, I think, him or her, and took a picture of them, from this perspective. So that was important to keep. So they took out some unsuitable material at the bottom of the retaining wall of the existing, the road is way, way up here. So they had this little area to work with, have a very unique shaped Perc-Rite system, and that's what it looks like today. So what a beautiful, beautiful result for this homeowner who really cared about the environment, cared about his family, and came up with a solution. And hopefully, and a lot of the neighbors are actually starting to implement this and protect the lake. So what are some trends in growth for Perc-Rite in New England? And the growth is in the municipal large flow applications. So the first example I want to share with you is Bonnie Eagle High School in Standish, Maine. So this is an existing high school that has an overboard discharge permit into the Saco River that their peak flows are about 22,000 gallons per day when school is in session. So as you can imagine, when you're dealing with a school and peak flows, it's very challenging from a treatment standpoint to deal with the ups and downs and maintain the levels. So the state asked them, because the levels were kind of up and down a little bit, they wanted them to go subsurface. So they designed a Perc-Rite system, and most of the construction has taken place already in the fall. So the building is already in place. All of the force mains are installed. All of the Perc-Rite zone beds have been prepped, and the equipment, Perc-Rite hydraulic unit, the pumps, everything is all in place. And we're just waiting for spring to happen so we can install the drip tubing and turn it on. Here is the site plan. So you can see the force mains coming down. The plant is kind of off the map here. And then we can have a series of zones, all different elevations. So we're following the contour. And we have different irregular shape zones as well. We provided the engineer all the zone layouts that they needed, and provide the friction loss calculations that they confirmed till the proper size force mains were and pump was selected. Here's a rendering of the hydraulic unit. In this case, we're using the suction lift pumps that I talked about earlier. And there is the unit itself being installed in the treatment building. And then this is a drone picture. This is the treatment building. We have the pump station that the suction pumps are drawing out of. This road is where the force mains were installed into the drip dispersal field. And I actually have a video of this, of my drone, the last time I was there, that I flew over the site, that I'll post on my YouTube channel so you guys can see it. That's really cool site. The next project that I'd like to talk about is Bromley Mountain, located in Peru, Vermont. They are looking to add 80,000 gallons per day of peak flows. So they want to build more rental units, more housing, so that they can attract people to spend the weekend and lodge up there. So in order for them to do that, they had to go through a quite unique experience. So where they want to propose the development, it's basically along, there's a brook downslope from the development, and that is dumping into a water supply. So the environmental concern here is very high. So the state of Vermont DEC, required a phosphorus study to make sure that there was going to be no phosphorus impact into this brook and therefore carry into the water supply. So we built a temporary Perc-Rite system. They built a lagoon and trucked wastewater from their plant up the road into the lagoon, and we pumped it into the exact location that they proposed, the 80,000 gallon per day system. So we replicated the loading rate that was proposed for 80,000 gallons per day that would take up, a lot more of this area. And then there were downhill and uphill monitoring wells, so so we could measure the impact of the phosphorus. Here are the operators kind of plowing that tubing into the grades. They're following the contour. You can see the type of equipment they used. Here is what the site looks like. So here's that road. This is where we tested some of it. This is the open field that they need to build all of the drip dispersal zones. And then these are the zones that were laid out in the zone configuration. So what's important about this is that the state acknowledged that the Perc-Rite test system removed all of the phosphorus. So there was zero impact of phosphorus, zero non-detect in the monitoring wells, so that they issued a permit for 80,000 gallons per day. Now, because of COVID, the project was not able to get started, and it's going to get started in 2021. So keep an eye out for updates on this project. We'll be posting a lot of videos and information because it's quite interesting based on the nutrient loading impact and decision making on why they went with Perc-Rite on this site. In the last project I want to talk about, so the town of Bridgeton, Maine is building a Perc-Rite system that will have peak flows of 160,000 gallons per day. So as you can imagine, building treatment plants for entire municipalities is very, very expensive. So what Maine decided to do is to build a smaller package plant and redirect flows from their downtown area into this plant and discharge it into an unused kind of sloping wooded parcel of land that was acquired for a very reasonable cost. So in this whole we started working on this project in 2015. It was permitted in 2020, and we are starting construction in 2021. So here is the mini treatment plant, and it's pumping up into this wooded site of 6 very large zones. This is like 100 scale, so these zones are very, very big. You can see them here in more detail. This is the treatment plant. This is our hydraulic unit, lift pumps, zone valves, all of the things needed to have a successful project. And since it hasn't been built yet, that's kind of all I have. Are there any questions? So I wanted to thank you, but before I thank you, we have a few more minutes, and I thought we might have been over time, so I have a couple of things I wanted to show you. Let me walk you through one more site. This is kind of my backup plan, just in case if things run a little ahead of schedule. So I'll close with this. So Oakson started in the early 2000s. Perc-Rite was first installed in Massachusetts in 2006, New Hampshire 2011. So our first system was 2006. And we got a call right when the lockdown occurred in March of 2020 from a real nice homeowner who said, hey, I just bought this house last year, and because of COVID, I live in New York City, and this was kind of like a little weekend summer getaway and whatnot, but I've decided to bring my family here and quarantine here. And 2 weeks in, I got this alarm on this control panel on the side of my house. So I opened up the control panel and I saw a sticker, American Manufacturing. I contacted them, and they said, oh, Oakson is the person that can help, the company that can help you in New England. And so the guy called Oakson. So Charlestown, Rhode Island is located on the Long Island Sound, very close to Mystic, Connecticut, but it's very close in proximity to the University of Rhode Island. And some of you folks may know that the University of Rhode Island has an academic center for wastewater and those who are looking to get into the health the health agent or environmental health field. And in that demonstration center, they have a lot of treatment systems like above ground, so you can kind of see what they look like and how they work. And you can see like chambers, and you can see all these different things. The university owned 56 Thomas Street in 1998. The university, the professor contacted American Manufacturing because they learned about Perc-Rite Drip Dispersal and said, hey, will you donate one for academic purposes? American said, sure. So they shipped the Perc-Rite system to URI, and URI built it at 56 Thomas Street in Charlestown, Rhode Island. After a couple of years of demonstration, the university decided that to sell this house. And now this Perc-Rite system was in use in a residential capacity in like 2001, but nobody knew about it because it was installed really not under the jurisdiction of the health departments, but kind of as a test center. So it's kind of one of those things, and we've all seen them before, where it kind of flew under the radar. And there are systems out there, you know, lagoon systems and things that, you know, kind of the states don't know about. And this one was by accident. So I said to the homeowner, I have no idea what you're talking about. There's nothing on my database of installations. So he said, well, I got these pictures of these plans that were included, you know, I found like in like a cabinet in the house. So he took pictures of them and sent them to me, and come to find out, it is a Perc-Rite system with a design date of 1999. So I contacted American Manufacturing, and they said, yeah, we sold a system to URI. And I contacted URI, and they told me all about it. And this is like the missing link. This is Sasquatch. This is the Loch Ness. This is something that we had no idea. We heard rumors about it, and we thought it was a myth, but it was the real deal. So I'm like, I need to go out there. So I told the homeowner, absolutely, I will be out there next week or a couple days. I forget what the exact dates were. So I went out there, and he's quarantined in the house, and I have my mask on, and I look at this control panel, and it looks very similar to the ones that we use today, but the technology, the microprocessors and stuff have been upgraded. Then I looked at the hydraulic unit. Looks very similar to the ones we use today. Some of the valves have changed. So why did the alarm go off? Why did this Perc-Rite system go into alarm? The answer is there were critters nesting in it, and they bit off the wires and the hydraulic tubing. This was a 3-zone system, and the system was working because as a critter bit through one zone, it had 2 to work on. As it bit through 2, it had 1. And then when it bit off the last one, the pump had nowhere to go. So what's kind of the moral to this story is every Perc-Rite system installed by Oakson, we have details on our plans to say to bed the hydraulic unit with stone around it, set the box, and then bed stone around the box to prevent a barrier so critters can't burrow in. Because this one was built without the oversight of Oakson, in our experience, the critters nested in there and cut all of the wires and the ability for the zones to work. Well, the end of the story is I had the parts on hand to put it back in operation, and this nice homeowner went on Google, and Oakson has a total of 3 reviews, but they're all 5-star. So he wrote a nice review saying about his system was running, and since 1998, it had no maintenance, but it's built to last. And that is the end of a Shakespearean tragedy, which turned into a happy ending. So if there are no further questions, I will dismiss everyone 5 minutes early. On behalf of Oakson, thank you for taking your time today. You'll receive an email later on with your credits for attendance today. And again, I asked you earlier on, we've done thousands of systems and have so many successful applications. And I scratch my head every day saying, why do I only have 4 in New Hampshire? Maybe we're doing something wrong. Maybe we're not getting the word out properly. Maybe we're not spending enough efforts with the good engineers who work in New Hampshire. But, you know, let us know. We would love to do work there and provide this great product to you, to all you folks and to your clients. So have a great weekend, everyone, and we're here for questions. And thank you again for your time. Take care.